Linear and quadratic equations. First, let's define a solution set. The solution set for an equation is the set of all numbers that, when used in place of the variable, make the equation a true statement. Second, two or more equations with the same solution set are called equivalent equations. Let's consider the equation 2x plus 3 is equal to 15. The solution set for this equation is the set containing the number 6, or we will simply write x is equal to 6. Now, why is that the solution set? Well, if we take the number 6 and we plug it in for the variable x, this equation becomes 2 times 6 plus 3 is equal to 15. And I'll put a little question mark here because we're going to verify this is true. 2 times 6 is 12. And yes, it is true that 12 plus 3 is equal to 15. And so we end up with 15 is equal to 15. So 6 is the number, and in this case, it's the only number that makes this equation true. Now consider the equation 5 minus 3x is equal to negative 13. We could also show that 6 is the answer to this equation. So once again, x equals 6. So because these two equations have the same solution set, these equations here are called equivalent equations. Even though you can see the equations are different, they are considered equivalent because they have the same solutions. The most important and most common type of equation in mathematics is a linear equation in one variable. So a linear equation in one variable is an equation that can be put into the form ax plus b is equal to c. Now a, b, and c are constants, and the number a cannot be 0. And x is what we would call the variable. So for example, all of these equations that you see here, 5x plus 3 equals 2, 2x equals 7, 2x plus 5 equals 0. These are all linear because they are all in the form ax plus b equals c, or we can put them in the form ax plus b is equal to c. Now, another thing to point out about linear equations, the defining characteristic of a linear equation is that the variable in the equation is raised to the first power. That's what really determines whether an equation is linear or not. That's the main thing, I should say. Now, how do we solve linear equations? Well, we have a couple of properties of equality that you have probably learned at some point. The first property says that if two things are equal, you can add the same thing to both sides of the equation. And the other property says if two things are equal, you can multiply both sides by the same number as long as you're not multiplying by 0. So let's solve the equation that you see here. 3a minus 5 equals negative 6a plus 1. Now, we'll go over a strategy in just a minute here, but the basic strategy is pretty simple. To solve for the variable a, what I want to do is get all the variables a on one side of the equation. So what I can do here is I can add 6a to both sides of the equation, because adding 6a to negative 6a will cancel that out on the right-hand side. And on the left-hand side, 3a plus 6a is 9a. So we now have 9a minus 5 is equal to 1. Now what I want to do is get the negative 5 on the other side of the equation. So I only want my a on the left-hand side of the equation. So to get rid of the negative 5 there, let's add 5 to both sides. Now I'm adding 5 because negative 5 plus 5 is 0. And we have 9a, and on the other side equals 6. Now to solve, all I need to do is divide both sides by 9. Now I should point out, when you divide by 9, that's the same as multiplying both sides by 1/9, right? So you can look at it either way. In this case, I think division is a little bit nicer. But what happens here is 9 divided by 9 is equal to 1. So we end up with 1a, which is a, and then 6 divided by 9 can be simplified to 2/3. So the solution is a equals 2/3, and if you do that as a solution set, you would just put the number 2/3 in these curly brackets that you see here. Now, I'm perfectly fine if you just write a equals 2/3, but sometimes you'll actually have to put the numbers into a solution set notation. Second example, we have another linear equation, 2/3 x plus 1/2 is equal to negative 3/8. When an equation involves fractions, the most effective way to solve that equation is to eliminate the fractions. So let's identify the least common denominator between 3, 2, and 8 is 24, right? 24 is the smallest number that 3, 2, and 8 all divide into, okay? And that's because 3 times 8 is 24, and 2 is already a factor of 8, right? So what I'm going to do here is multiply both sides of this equation by 24. Now, when we do that, we're going to distribute, so we get 24 times 2/3 x plus 24 times 1/2 equals, and on the other side we have 24 times negative 3/8. Now, why am I multiplying by 24? Well, remember, 24 is like 24 over 1. And so we can do some cross-canceling. 3 goes into 24 8 times. And what we have left here is 8 times 2 times x, which is 16x. So the fraction's gone. Plus, next, 2 goes into 24 12 times. 12 times 1 is 12. And on the other side, 8 goes into 24 3 times, and we have 3 times negative 3, which is negative 9. Okay, so now the fractions are gone. How do I solve for x? Well, I'm going to subtract 12 from both sides, and that gives us 16x is equal to negative 21. And then dividing both sides by 16, we end up with x is equal to negative 21 over 16, which, seems like kind of a strange answer, but answers can be fractions, and they can be fractions that are not reducible. Now, you could always check this answer. So if you want to check this answer, you would simply take negative 21 over 16, and you would plug it in for x here. And then we would need to verify, is this equal to negative 3/8? Well, we could do some canceling. 3 goes into 21 7 times. 2 goes into 16 8 times. So we have negative 7/8 plus 1/2. Remember that 1/2 is 4/8, right? If I just multiply by 4 here and here. Is that equal to negative 3/8? And the answer is yes, because negative 7 plus 4 is negative 3. So we have negative 3/8 is equal to negative 3/8. So our solution, negative 21 over 16, is correct. The next equation has decimals. Now, one way to deal with decimals is to just simply use a calculator and do everything the same. So in this case, what I'm going to do is, first of all, let's get rid of the parentheses. Most of the time when you're solving equations, you don't want to have parentheses. So we have 0.06x plus, now we've got 0.05 times 10,000. Now you could just do that on a calculator. So this is going to give us 500. And then we have 0.05 times negative x, which is negative 0.05x, and then equals 560. And then we'll simply combine like terms here. So 0.06x take away 0.05x is 0.01x, plus 500 is still there, equals 560. And now from here I can subtract 500 from both sides. And that gives us 0.01x is equal to 60. And our last step here, we'll divide both sides by 0.01. And 60 divided by 0.01, again, you can just use a calculator for this. That's going to be 6,000. Okay, and that would be our answer. Now, of course, you could check that answer. The other way to do it is you could get rid of these decimals here by multiplying both sides of the equation in the beginning by 100. So if I were to do that, let's multiply the left-hand side of the equation by 100 and the right-hand side of the equation by 100. You have to be really careful here because we're going to multiply 100 times 0.06, which gives us 6. So we're going to have 6x there. And then the 100 here only gets multiplied to the number outside of the parentheses. So 100 times 0.05 is 5. And then the 10,000 minus x does not get multiplied by 100. And the reason for that is because these are already multiplied together. So when you multiply the 100 here, in the next step, that 5 is going to be distributed. On the other side, we have 560 times 100, which is 56,000. Now, I don't think this is a really big advantage. Some people like to do it this way, but let's go ahead and continue. 5 times 10,000 and then 5 times negative x is going to give us positive 50,000 and then negative 5x equals 56,000. 6x take away 5x, that's just going to be x. And then you can see that to solve for x now, I'm just going to subtract 50,000 from both sides, and that gives us x is equal to 6,000, same answer. So here are the steps to solve a linear equation. We've already done multiple examples, but basically you want to simplify each side of the equation separately. So if you can remove parentheses or combine like terms or anything like that at all, simplify each side of the equation first. Then we use the addition property of equality to get all the variable terms on one side and all of the non-variable terms on the other side. And then we use multiplication to solve for our variable, and then step 4 is check your solution. Now, a lot of people don't check their solution, especially if you're doing your homework in a computer system. Most of the time we just plug it in and we hit enter, and if the answer is correct, then we're good. But you can check it by plugging it back into the original equation. So let's take a look at another example of a linear equation. This one's a little bit more complicated. All right, so what should we do first? Well, remember, the first step said simplify each side of the equation as much as you can. Well, the right-hand side is 35, so there's nothing to do here. But on the left-hand side, we have quite a lot to do. So how do we simplify this? You have to be very careful because it's tempting to want to say that 8 minus 3 here is 5. But we don't do things in that order. We're supposed to multiply before we add and subtract things. So we need to multiply out the parentheses here first. So this is 8, and then negative 3 times 4x is negative 12x, and negative 3 times negative 2 is positive 6. And then we also have 5x, and then equals 35. This is the correct way to do it. Now we're going to combine like terms. So notice I have a negative 12x and a positive 5x. Those will combine together to give us negative 7x. And then positive 8 and positive 6 is positive 14, and then equals 35. So you can see the left-hand side simplifies into negative 7x plus 14. Now there's nothing else I can do to simplify this. So now I want to get my x variable all by itself, which means I need to get rid of that positive 14. So let me just subtract 14 from both sides. This is going to give us negative 7x is equal to 21. And then our last step, we're going to divide both sides by negative 7, because negative 7 divided by negative 7 is 1. So that's 1x, and on the other side, 21 divided by negative 7 is negative 3. Now we're going to move into the second most important type of equation in algebra, and that is the quadratic equation. Any equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are constants, and x is a variable, is called a quadratic equation. One important thing, a cannot be 0. So think about that for a minute. Why is it that a cannot be 0? Because a quadratic equation, the defining characteristic is that it is second degree. So we need the number in front of x squared to not be 0. All right? Now, when you write an equation in this particular form, this is called the standard form for a quadratic equation. So all of these here are quadratic equations. Only the last one is in standard form. So notice that you have 4x squared minus 3x plus 2. So you can make a direct correlation. A in this problem is 4, B is negative 3, and C is positive 2. These equations are not in standard form, but you could easily put them in standard form by simply setting it equal to 0, right? So in this problem here, we could subtract 5x and subtract 3 from both sides, and then we would have it in standard form. And likewise here, we could subtract 75 from both sides, and then we would have it in standard form. Now, why do we like it in standard form? Well, because when we go to solve a quadratic equation, we're going to use something called the zero factor property. The zero factor property says if you have two numbers, r and s, r times s can only be 0 if either r is 0 or if s is 0, or both could be 0. So we like it in standard form because we like our quadratic equations to be equal to 0 so that we can use the zero factor property. So let's solve our first example here of a quadratic equation. X squared minus 2x minus 24 is equal to 0. Okay, so it's in standard form because it's equal to 0. So check that. We like that. Now what we need to do is we need to factor the left-hand side. And to factor that, I'm going to do a magic X. Now you don't have to do a magic X. In this case, I think it's pretty easy to factor, but let's do a magic X anyway, just to review it. So we have a 1x squared here. So we're going to multiply 1 times negative 24 is negative 24. We have a negative 2x in the middle, so I'll put a negative 2 there. And remember, the magic X says you're looking for two numbers that multiply to give you negative 24 and add to give you negative 2. And those two numbers are negative 6 and positive 4, right? Because negative 6 plus 4 is negative 2, and negative 6 times 4 is negative 24. So x squared minus 2x minus 24 factors into x minus 6, x plus 4. And here's the other thing. In this case, the number in front of x squared is 1. Remember, when you do your magic X, you are supposed to divide each of these numbers by the number in front of x squared. But when it's 1, you can actually skip this step, right? Because 6 divided by 1 is 6, and 4 divided by 1 is 4. So that is the factorization. Now, the zero factor property says the only way this multiplied by this can equal 0 is if either the first factor is equal to 0 or the second factor is equal to 0. And then from here, I can solve each of these equations very easily by, in this case, adding 6, and over here, subtracting 4. And we get two solutions. We get x equals 6 or x equals negative 4. Now, you can write that together like this. This is what we usually do. Or you can put these two answers in a solution set. Either way. So one thing I want to kind of point out at the end here is notice that quadratic equations, which are second degree, are going to typically have two solutions. Okay, not always, but most of the time they're going to have two solutions. And that is not a coincidence. So how do we solve quadratic equations by factoring? Well, what we do is we write the equation in standard form, which means make sure that it is equal to 0. And then we factor the left side of the equation. After that, we use the zero factor property to set each of the factors equal to 0. That's going to give you multiple simple linear equations. We solve each of those. And then the final step is you could check your answers. So let's take a look at this next example. 100x squared is equal to 300x. So if I follow the rules here, the first thing I'm going to do is I'm going to put it in standard form. It's very tempting in this case to divide both sides. Please don't do that. Let's subtract 300x from both sides. That will give us 100x squared minus 300x is equal to 0. And then what I'm going to do is factor out the greatest common factor. Now, the greatest common factor in this case is we can pull out a 100, and we can also pull out an x. And if we do that, all we have left over is x minus 3. So notice that we do not need to use a magic x to factor this one. This is simply greatest common factor. Now we'll take the first factor, which is 100x. We'll set that equal to 0. And we'll take the second factor, x minus 3, set it equal to 0. The second equation there is very simple. We just add 3 to both sides, and we get x equals 3. And the other one's a little bit confusing sometimes for students, but this is 100 times x. So to solve this for x, we just divide by 100, right? Because that cancels that out, and we end up getting x is equal to 0 divided by 100, which is 0. So we have two answers. We have 0 and we have 3. And of course, we can write that as a solution set. In the next problem, notice that you don't see an x squared in this problem, but if you were to multiply x times x, you would get an x squared. And also notice that it's factored on the left-hand side, which kind of seems like a good thing, but in this case, it's not a good thing, because on the right-hand side, we do not have 0. We must have 0 over here. So the first thing we're going to do is multiply this out. So on the left-hand side, we are going to FOIL. And when we do that, we'll have x squared plus 1x minus 2x minus 2 equals 4. And that is x squared minus x minus 2 equals 4. And then I'm going to subtract 4 from both sides because I want to set this equal to 0. So that gives us x squared minus x minus 6 equals 0. Now it's in standard form. So now all I need to do is factor x squared minus x minus 6. You can use a magic x if you want, but this factoring is actually pretty simple, pretty straightforward. And then I'll just set each of these factors equal to 0 and then solve each equation. And that is going to give us two answers. Now, this next example is a little bit different. Notice here we have a third degree equation, which is a little bit out of the ordinary from the title of this section, right? The title here is Linear and Quadratic Equations. This is not a quadratic equation because we have a third degree here, but it can be done very similarly. So the first thing I'm going to point out is that it is equal to 0, which is good. And so what we need to do is factor the left-hand side. But this is not going to be a magic X type of factoring. This will be grouping because we have 4 terms. So out of the first 2 terms, the greatest common factor here is x squared. So if we pull out an x squared here, we have x plus 2 left over. And out of the second 2 terms, we can pull out a negative 9. And we will also have x plus 2 left over. So this is good. Now we're going to factor out the x plus 2, which will leave us with x squared minus 9 left over. And then don't forget, you have to factor completely. And so x squared minus 9 factors into x minus 3 and x plus 3. So the factoring is a little bit different, but in the end, notice you have multiple factors multiplied together set equal to 0. So to solve this, all we need to do is take each one of these factors and set them all equal to 0. And then solve each of the corresponding equations. So in the end here, we have 3 answers. We have negative 2, positive 3, and negative 3. We could write the answer like that. And we can also abbreviate the answer since we have positive and negative 3. You can write it like this. And of course, you can also put it in solution set notation. Our next example is an application. Suppose we have a boat is traveling upstream against a current. If the speed of the boat in still water is r and the speed of the current is c, then the formula for the distance traveled is distance equals r minus c times t, where t is the length of time. Now in this problem, we just want to solve for c if we know that d is 52 miles, r is 16 miles per hour, and the total time is 4 hours. Let me explain the formula first. So if you are in a river and the current is flowing, say, in this direction at a certain speed c, so c is the current, if you are trying to travel against that current at a rate r, right, so the r is the rate or speed of the boat in still water, the current is going to act against however fast the boat is trying to go. So the net speed of the boat, right, is going to be r minus c. It's how fast the boat would be going in still water minus how fast the current is going. And then we know from basic algebra that the distance is equal to the rate multiplied by the time. But the rate is r minus c. And so that's where this formula comes from here. Distance is equal to the overall rate, which is r minus c, multiplied by time. So now in this case, to solve for c, all we have to do is plug in d, r, and t into this formula. So what that means, since we know that d is 52, we get 52 is equal to r is 16, minus c we don't know, and then multiplied by t equals 4. So we have 52 is equal to 4 times 16 minus c. Now to solve this, there's a couple of different ways you could do it actually. You could multiply it out, so you could have 52 is equal to 4 times 16 is 64, minus 4 times c is negative 4c. And then simply subtract 64 from both sides, which gives us negative 12 equals negative 4c. And then dividing both sides by negative 4 gives us c equals 3. Okay, so that's one way to do it. But you can do it a little bit differently. So when we go to solve this equation right here, this 4 that's factored out, you could choose to divide by 4 in the beginning. And that would cancel that 4 out. And 52 divided by 4 would be 13 equals 16 minus c. And then from there, just subtract 16 from both sides. And that would give us negative 3 equals negative c. And then finally, if we divide both sides by negative 1, we get c equals 3. Both methods are fine, just want to give you options. Our next example is another application. If an object is projected into the air with an initial vertical velocity v, its height h after t seconds will be given by the formula h equals v times t minus 16 times t squared. So find t if v equals 64 and h equals 48. So another way to say this would be to say, how long does it take for the object to reach a height of 48 feet if its initial velocity is 64 feet per second? Right? That would be another way to ask this question. All we have to do to answer it is plug in the value. So we know that h is 48 feet, so h becomes 48. We know that v is 64 feet per second, so v right here becomes 64. And then we have t and then minus 16 t squared. So what you have here, notice, is a quadratic equation. You have a second degree equation. I'm going to solve that by putting it in standard form, which means I need to set it equal to 0. Now, I could subtract 48, or I could move these two terms to the left-hand side. I am going to move these terms to the left-hand side because I don't want a negative in front of my t squared if I don't have to. So I'm going to add 16t squared to both sides, and I'm going to subtract 64t from both sides. And when we do that, the left-hand side becomes 16t squared minus 64t plus 48, and the right-hand side, of course, just becomes 0. Now I'm solving this quadratic equation. How do we solve quadratic equations? We factor. Now, before you make a magic x, notice that 16 goes into all of these numbers. So we can factor out a 16, and we will have t squared minus 4t plus 3. And that makes the factoring of what remains much easier. So how do we factor t squared minus 4t plus 3? We can make a magic x, or we can simply figure it out because these numbers are very small. It's going to be t minus 3 times t minus 1. Then we set each of these factors equal to 0, and we are going to get two solutions, 3 and 1. Okay? So it says, find t if these things are true. Why are we getting two values for t? Does that even make sense? Well, let's think about it. If an object is fired up into the air, as time goes by, it's going to come down and hit the ground. So we are asking, when is it going to be 48 feet above the ground, right? A height of 48 feet means 48 feet above the ground. Well, you can see it's going to pass 48 feet on the way up, and it's going to pass 48 feet on the way down. So this location right here, this is where t is equal to 1 second, and this location right here is where t is equal to 3 seconds. So that is why we are getting two answers. Another thing that will be expected from students in this course is you should know some basic facts from geometry for area and perimeter of a square, a rectangle, and a triangle. So remember, perimeter is the distance around. So for a square, it's s plus s plus s plus s, which is 4s. And the area is basically length times width, which is s times s, which is s squared. For a rectangle, the width and length are different most of the time. So the perimeter is 2 times the width plus 2 times the length, and the area is basically just length times width. And for a triangle, the perimeter is a plus b plus c, and the area is 1/2 times the base multiplied by the height. So you should know these formulas for these geometric shapes. Now, as an example, suppose we're given the formula for the perimeter of a rectangle. P is equal to 2 times W plus 2 times L, right? So that's 2 times the width plus 2 times the length. We want to solve this for W. So a formula is simply an equation that has 2 or more variables. In this case here, we have 3 variables. We have P, W, and L. Right now, this formula is solved for P, but we want to solve it for one of the other 2 variables. So how do I solve this for W? Well, basically, I just want to get W all by itself on one side of the equation. So we can subtract 2L from both sides. This gives us P minus 2 times L is equal to 2 times W. And then to get W all by itself, I just need to divide by 2 on the right side and also divide by 2 on the left side. This will give us W is equal to, and you got to be very careful here. Do not cancel these 2's here. Remember, you cannot cancel terms. The only way you'd be able to cancel a 2 here is if you also had a 2 here, which we do not. So we're just going to write this as P minus 2L divided by 2. Okay, so this is one way to write the answer. Now, you can do this if you want. You could write it as P divided by 2 minus 2L divided by 2. So you could separate the fraction. And if you choose to that, you could then cancel the 2 here. Okay, but it would still be P over 2 and then minus L. So either one of these is fine. In our next example, we have AX minus 3 is equal to BX plus 5. Notice that this is an equation that has 3 variables, A, B, and X. And we want to solve for X. So to solve for X, once again, notice that we have an X here and we also have an x here. We need to get all the x's on one side of the equation and all of the non-x's on the other side of the equation. So what I'm going to do here is I'm going to add 3 to both sides. Okay, that's going to get rid of the number here. And I'm also going to subtract bx from both sides because that will get rid of the bx there. And what we have is ax minus bx equals 5 plus 3, which is 8. Okay, so I have all the x's now on the left-hand side, but how do I get these x's by themselves, right? Like, how do we make one occurrence of the x here? Well, notice that x is a common factor, so we could just factor that out. So we have x times a minus b is equal to 8. And then to solve for x, I just need to divide by a minus b. So we have x is equal to 8 divided by a minus b, right? Because that's just canceling those out there. And that's our answer. Okay, let's go back to linear equations. Let's solve for x here. We have 2 times 3x minus 4 is equal to 3 plus 6x. Let's multiply this out. 2 times 3x here is 6x. 2 times negative 4 is negative 8. And on the other side, we just still have 3 plus 6x. Now to solve here, I need to subtract 6x from both sides to get the x's on one side of the equation. But when you do that, something unique happens here. All of the variables cancel. And what you end up with here is negative 8 is equal to 3. And this, of course, is false, right? It is not true that negative 8 is equal to 3. So because this is a false statement, what that means is that this problem has no solution. So when your variables completely cancel out, that's a special case. And this is technically not a linear equation, okay? Because a linear equation, remember in the beginning, we said it was ax plus b is equal to 0, and we said that a cannot be equal to 0. Well, when your x's cancel out, it's kind of like having a 0x, okay? So this is technically not a linear equation. You don't have to really think about that. All you need to know is that this equation has no solution. And one final example here, this one is very similar to the last problem. We have negative 15 plus 3x is equal to 3 times x minus 5. To solve this, let's go ahead and multiply it out. We have negative 15 plus 3x is equal to 3x minus 15. Same as the last example, I'm going to subtract 3x from both sides to attempt to get all the x's on one side, but once again, they all cancel out. But this time, we have negative 15 is equal to negative 15, and this is a true statement. So what does this mean? Well, this means that our solution is all real numbers, okay? So any number that you plug in is going to make this equation true because it's always going to give you the left-hand side is equal to the right-hand side regardless of what you plug in for x, right? Because the x's are canceling out and you have the same number left over, okay? So this is kind of the other extreme that can happen. Now, this again is not a linear equation. It's a special kind of equation. Technically, it's called an identity, but we just need to know that the solution is all real numbers. And that concludes this video lesson.